Welcome dear learners to another video for BSc third year 5th semester. In continuation to our previous video, in this video we are going to discuss the second part of physical properties and molecular structures. This video consists of one important physical property, that is magnetic property, and its measurement by Gauss balance method, and how magnetic property helps in structure determination. So this is the content of this video. This is a Gauss balance. This is used in the measurement of magnetic property. So before that, we will discuss some classification of substances on the basis of magnetic property. So on the basis of magnetic properties, substances are classified into ferromagnetic, paramagnetic, and diamagnetic. So these are the three important class of the substances on the basis of magnetic property. Now we will discuss all the differences between these substances. First, physical state. Ferromagnetic substances are solid, paramagnetic substances may be solid, liquid, or gas, and diamagnetic substance they may be solid, liquid, and gas. Effect of magnet. In presence of magnetic field, ferromagnetic substances are strongly attracted by magnet. Paramagnetic substances are weakly attracted by the magnet, while diamagnetic substances are strongly repelled by magnetic field. Third point of difference is behavior under non-uniform field. In presence of non-uniform field, ferromagnetic substances tends to move from weaker to the stronger field, while paramagnetic substances tends to move from weaker to stronger field, and diamagnetic substances move from stronger to weaker field. Next point is behavior under external field. Ferromagnetic substances preserve the magnetic property after the external field is removed. Paramagnetic substances, they do not preserve the magnetic properties once the external field is removed. And diamagnetic substances, they do not preserve the magnetic properties once the external field is removed. Effect of temperature. Above Curie point, it becomes paramagnetic. So ferromagnetic substances become paramagnetic above Curie temperature. Paramagnetic substances, with the rise of temperature, it becomes diamagnetic. And on diamagnetic substances, there is no any effect of magnetic properties. Next is permeability. Permeability value is very high for ferromagnetic substances, and it is of the order 10⁻³. While for paramagnetic substances, it is greater than 1, and for diamagnetic substances, it is less than 1. Susceptibility value, magnetic susceptibility value, it is very high and positive for ferromagnetic substances, a little bit greater than unity and positive for paramagnetic substances, little less than unity and negative for diamagnetic substances. And here are some examples of these three classes. First, ferromagnetic substances. Fe, Co, and nickel, iron, cobalt, and nickel are the example of ferromagnetic substances. Lithium, titanium, manganese, aluminium, molybdenum, chromium, and zirconium are the example of paramagnetic substances, while copper, silver, gold, silicon, zinc are the example of diamagnetic substances. Now, then we have magnetic susceptibility. Magnetic susceptibility is if a material is placed in a magnetic field, the strength of the magnetic field in the material is called as magnetic induction. And mathematically, if H is the strength of applied magnetic field, and B is the magnetic induction in the given material, then B magnetic field B is equal to H plus 4 pi into I, where I represent the magnetic moment per volume in the material, and it is called as intensity of magnetization. So it may be positive or negative depending upon whether the material is paramagnetic or diamagnetic. And the intensity of magnetization produced per unit strength of applied magnetic field is called as specific magnetic susceptibility. And it is usually represented by psi, and mathematically it is equal to I upon H. Now magnetic permeability. If two magnetic poles of strength M1 and M2 are separated by a distance r, then the force F acting on them is given by F is equal to 1 upon mu into M1 multiplied by M2 divided by r square, where quantity mu in the above expression is called as magnetic permeability of the medium between the poles. It is defined as the relative tendency of the magnetic lines of force to pass through the medium as compared to that in the vacuum. So for vacuum, mu is taken as equal to 1. Similarly for air, mu is taken approximately equal to 1. Now we will go for the Gauss balance method that is used for the measurement of magnetic property. So magnetic property of the substance is depend on the number of unpaired electron present in it. So unpaired electron produce its own magnetic field, and that magnetic field produced by unpaired electron interacts with external magnetic field, and on the basis of behavior of this interaction between two magnetic field, we have classified substances into three different types such as ferromagnetic, diamagnetic and paramagnetic. Now this magnetic property of a substance is measured by using a method that is called as Gauss balance method. So it is simply a chemical balance. It is similar to a chemical balance, and which is used to measure the magnetic property. So first we discuss the steps involved in the measurement. A finely divided powder or a solution is taken in a glass tube that is called as Gauss tube. Measure the weight of the substance in presence and in absence of magnetic field. And what observation we get during the measurement? If the substance is paramagnetic, then it will weigh more than in absence of field. Increase in weight is the measure of paramagnetism of the substances. See how this is working. So this is a Gauss balance. It is similar to it is very much similar to a chemical balance. Generally in chemical balance, we have two pans. Here we have only one pan, and to another side we have a tube that is called as Gauss tube. So in this Gauss tube, a material that is used for the measurement of magnetic field, it is filled, and initially the weight and the tube is in balanced position. Now when external magnetic field is applied, then there is an interaction between the magnetic field applied and the magnetic field of the material. So if the material is paramagnetic, then it repelled by the external magnetic field. Sorry. If the material is if the material is paramagnetic, then it is attracted by external magnetic field, and to balance this, it is attracted by the magnetic field, and there is imbalance. Okay, so to balance it, some weight must be added in this pan. So in this way there is increase in weight. So hence we have made this statement: increase in weight is the measurement of paramagnetism. And reverse thing is happening if the substance present in this sample tube is diamagnetic. If the substance is diamagnetic, then it is repelled by the external magnetic field, and this pan goes up downward and this pan moves upward. Now to balance again, we must remove some weight from this pan. In this way, the weight of the substance decreases. So decrease in weight is indicator of that it indicates that the substance is diamagnetic. So in this way, Gauss balance method is working. So very simple method for measurement of magnetic property. Now there are some advantages and disadvantages associated with this Gauss balance method. We first discuss advantages of Gauss method. Apparatus is simple and easy to assemble. It is easy to handle. Chemical balance can measure change in mass. So large amount of sample have large forces. Now what are the disadvantages? Large amount of sample is required for the analysis, and if sample is not uniform filled in the sample tube, then it leads to some error in the measurement of magnetic property. So these two are the drawbacks. Now these properties, that is magnetic permeability, susceptibility, we have already discussed. The differences between paramagnetic, diamagnetic and ferromagnetic substances we have also discussed at the beginning of this video. And the last point is magnetic property for the structure determination. So on the basis of magnetic susceptibility value, we can decide magnetic nature of the substance. That is, either it is paramagnetic, diamagnetic or ferromagnetic. And on the basis of that, we can find out unpaired electron present in the atom. So this is helpful us in determining hybridization and structure. So this is all about magnetic property, its measurement and application in structure determination. Thank you.